In this video, we will learn how to find the confidence interval for population proportion using StatCrunch and how to write the conclusion based on our findings. I will also show you how to find the simple proportion and margin of error using formulas and from StatCrunch interval limits. So let's go. This problem consists of 4 parts. Let's read the problem. 50 randomly selected statistics students were asked if they actually read their statistics textbook. 35 responded that they do not read the textbook. Part 1. What is the value of p hat for this sample? Part 2. Identify the margin of error E. Part 3. Construct a 95% confidence interval for the proportion of students who responded that they do not read their stats textbook. Part 4. Write a statement that correctly interprets the confidence interval. We could use the formula to find simple proportion, p hat, and then find margin of error, and then construct the confidence interval using those 2 values. But let's jump right to part 3 and construct the 95% confidence interval for the proportion of students who responded that they do not read their textbook. And then we'll come back to part 1 and part 2. We will use StatCrunch. Go to Stat, Proportion Stats. One sample with summary. Since we are looking for the interval for the proportion of students who responded that they do not read their stats textbook, the number of successes would be 35 because 35 students responded that they do not read their stats textbook. 50 randomly selected students were asked, so number of observations 50. Then we need to change from hypothesis test to confidence interval and adjust the level if needed. In this case, it's not needed because we are constructing a 95% confidence interval, so our confidence level is 0.95. Complete. Let's write down the lower limit and upper limit that we got from the StatCrunch. I'm rounding the confidence interval limits to 3 decimals. That's what usually your homework will ask as well. Once we know the confidence interval limits, we can now find the simple proportion and margin of error. The simple proportion would be the upper interval limit plus lower interval limit divided by 2, 0.7. Another way to find the simple proportion, p hat, would be using the formula x over n. X is 35 divided by 50 will also give us 0.7. This was part 1. This is part 3. We're going kind of in different order. Now let's look at how to find the margin of error E. We can find it from the interval limits by subtracting the lower interval limit from the upper interval limit and dividing the difference by 2. We can also find the margin of error using the formula. Z of alpha over 2 multiplied by the square root of the quotient of the product of p hat times q hat divided by n. The only unknown in this formula is z of alpha over 2. We can find it using StatCrunch. Let me draw a diagram just to help us see what we're looking for. The confidence interval is 95%, so the confidence level is 0.95, which leaves on each end 1 minus 0.95 divided by 2 because we have 2 ends, 0.05 divided by 2, 0.025. So we are looking for the critical value z of alpha over 2 that separates the 0.025 on the right from the rest of the area. Let's use StatCrunch. In StatCrunch, go to Calculators, Normal. In the right box, change the area to 0.025, and we're looking for the area on the right, so change the direction for the probability to greater or equal to. The critical value is 1.96. We are rounding the critical value to 2 decimal places usually. We move the screen a little bit to give us some more space. And we will calculate now the margin of error E using all the values that we know. Critical value z of alpha over 2 is 1.96 times square root of p hat is 0.7 Q hat is 1 minus P hat. 1 minus 0.7 is 0.3. Over N is 50. We can use online calculator. I'm going to use the scientific calculator from desmos.com website. Very convenient. You just type what you see in the formula and you don't have to worry about order of operation. 1.96 times square root of 0.7 times 0.3. Well, actually, we do need to worry about order of operations for fractions because we are multiplying numerator first. So let's put it in the parentheses and then click divide by 50. And here's the answer, 0.126. The same as we received from this formula, upper limit minus lower limit divided by 2. Knowing the two values, sample proportion and the margin of error, we could build the confidence interval manually, but it's much faster to do it on StatCrunch. If you want to build the confidence interval manually, then keep in mind that the confidence interval for the population proportion in this case would be within the limits of sample proportion minus the margin of error to sample proportion plus the margin of error. The population proportion is within the limits 0.7 minus 0.127 to 0.7 plus 0.127, or within the limits of 0.573 to 0.827. The same what we got on StatCrunch. Now let's answer the last part. To write a statement that correctly interprets the confidence interval. I want to scroll to the confidence interval limit so we have it in front of us. Now remember, we are looking the confidence interval for population proportion. So we always say we are, in this case, 95% confident that the true value of population proportion is within the interval limits of 0.573 to 0.827. Or if you want to convert it to percentage, we're not asked in this case, but sometimes they do ask. That would be from 57.3% to 82.7%. I hope that was helpful. If you liked the video, click like. Check my other videos. I have a lot of videos on different math topics, and subscribe for the updates.